So here's some more notes for section 4.2, and these are mostly on notation. And these would be primarily considering problems 35 through 38. The book uses one kind of notation, and I use just like kind of slightly different. I kind of change things around just a little bit. So let's go over this so you kind of get an idea. In other words, the way that would write in the textbook for 35 through 38, and they actually want you to find a particular solution. They would say f prime of x equals 2x, find f of x. So we are looking for the antiderivative of f prime of x, or 2x. That means the function whose derivative is 2x, or f prime of x. So we could work it out like this. We'd say, well, f of x equals, and we take the antiderivative of this. So we would add 1 to the exponent, divide by that. So 2 times x squared divided by 2 plus c. And that ends up equaling x squared plus c, because f prime of x, the derivative of this, is just 2x. Now, I didn't use that notation on the antiderivative worksheet. I used the other notation, and this is the way I did the problems. So my solutions for 35 through 38, I just rewrote it. Instead of saying f prime equals 2x, I said f of x equals 2x, and we want to find the antiderivative of that, which is capital F of x. This is the more traditional notation, and we'll use this a lot as we go through these chapters. So we are looking for the antiderivative of f of x, or 2x, which is capital F of x. Okay, capital F of x. So that's the function whose derivative is f of x. That's what capital F of x is. It's the antiderivative. So in the same respect, what I did was I would say capital F of x equals the 2x squared over 2 plus c. Okay, which equals x squared plus c, as in above. But this is because capital F prime of x equals 2x. So these aren't related because I set up my notation differently. So don't look at these and say, well, this is confusing. No, this is a different. This is saying that this is the f prime of x. So this is the derivative of this function. And this is saying this is the derivative of this function. And this is what we're more familiar with. Okay. Now, an easy way to remember this is just always remember f prime, capital F prime of x equals f of x. Capital F prime of x equals f of x. In other words, the derivative of the antiderivative of a function is just that function. So this is what ties these two notations in. All right? So we're not talking about f prime up here, we're talking about capital F prime of x. Okay? All right, so let me work out an example like I did on 35 through 38, so you'll just see and get a little bit locked in. So instead of saying, f prime of x equals this, I'm trying to find f of x, what I said was f of x equals this, 4x plus 1, and the point 3, 2 belongs to f, capital F of x, and we want to find capital F of x, that's the antiderivative. Okay? So we know that my solution over here, we know that f of x, capital F of x, would equal, and that's going to be 4x, and then we're going to add 1, 2 divided by 2, plus, that's x to the 0, so I add 1, that makes it x to the first, and then plus c. So we know that. And we can simplify that, and we get capital F of x equals 2x squared plus x plus c. All right? Now we also know over here that 3, 2 belongs to f of x, so this would actually tell me that, and we also know that this is x, and this is capital F of x. This is our function notation, right? That's an ordered pair. So we know that this would really imply that capital F of 2, I'm sorry, capital F of 3, excuse me, equals what? 2. In other words, this is the x, this is the y, this is the x, this is what results when I put the value into the function. So that means that capital f of 3 equals 2. So wherever this is x, this is like x, and this is like the y, or the f of x. So if I could put this in, every time I see an x, I put a 3, I get this. So I'm just going to substitute this in so you can see. So every time so x is going to be 3. All right. So we find a particular solution. All right. And what's f of 3? Well, f of 3 is 2, so I can put a 2 here. So I know that this is going to be 2. And that's going to equal 3 squared is 9, so 2 times 9 plus 3 plus c. So 2 equals 18 plus 3 is 21 plus c. So if I subtract 21 from both sides, I get c equals, so I subtract 21 from both sides. I'm going to show you this. Just have to be careful because sometimes people mess up on this simple little step. So negative 19. So now I can put this back in my function over here. And now so I can say that capital F of x equals two x squared plus x plus c, which is negative 19. And there's your antiderivative. Okay? Now you can check this. It's real easy to check it. Let's take f prime, or capital F prime of x. So if I take the derivative of this, what do I get? I get 4x plus 1 minus 0. So that looks about right. And all we have to do is take capital F of x. Let's take f. And let's put that value in. The value was negative 19. I'm sorry, not negative 19. We said over here, we know that over here we are giving this assertion that 3, 2 belongs to f of x, or f of 3 equals 2. So every time I'll put a 3 in here. And f of 3 was 2. That equals, oops, should be squared, pardon me. And 2 times 3 squared is 9. I'm sorry, 3 squared is 9. 2 times 9 is 18, so 18. Oops. 18 plus 3 minus 19, which equals 21 minus 19, which equals 2. So that checks. Okay, so that satisfies both conditions. Okay. And you don't have to check it, but I just did it so you can see how this kind of works all the way around. All right, so that's kind of how we can find a particular value. We call this finding a particular value for this antiderivative, because we need to have at least one point that's on the antiderivative to find the actual antiderivative without the c. That's how we find out what c is. Okay, and that's the way you're supposed to do problems or that's the way I did using that notation. That's how I did problems 35 through 38. Hope that makes sense.